So this is a cartoon representation of an atom, and this is specifically lithium-6. Now you can tell that based on the information in the drawing. So we've got 1, 2, 3 protons in this drawing, and those protons are found in the nucleus. If we pull out our handy-dandy periodic table, we can see the element 3 over there is lithium. So the atomic number identifies the atom, and so 3 protons is an atomic number of 3, which means it is lithium, and anything with 3 protons will be called lithium. Back to our cartoon. In the nucleus, we also have 3 neutrons. Now, neutrons are neutral, so they don't contribute anything towards the charge, but they do contribute quite a lot to the mass. And so the protons and neutrons together in the nucleus make up the overwhelming majority of the mass of the atom. As a result, adding the number of protons and the number of neutrons together is a value called the mass number. So in this case, that's going to be 6. Now, you often see that represented in this way as lithium-6. Sometimes you also see the 6 written at the top of the symbol. Outside the nucleus, we have 3 electrons. Now, the 3 electrons are here because this is a neutral atom, so it has no charge. So because protons are positive, and there are 3 of them, in order to have a neutral atom, you also have 3 electrons. Now, there is organization to the area in the outside of the atom where the electrons are, but we're going to talk more about that later. For now, I just want you to know that electrons are outside the nucleus and the protons and neutrons are inside the nucleus. Now, I want to contrast lithium-6 and lithium-7. So a lot about these two atoms is the same. They both have 3 protons, which makes it lithium. They both have 3 electrons, which makes them both neutral. What is different here is the number of neutrons in the nucleus. So because we have 4 neutrons and 3 protons, that gives this atom a mass number of 7, making it lithium-7. So these two atoms would be called isotopes of each other. They are the same element, but they have different mass numbers, and that's called an isotope. Now I'm going to keep talking about lithium-7 for the rest of this video because it is the most common isotope of lithium. And one way that you can tell that usually, not always, is to look at the average atomic mass on the periodic table. Often, the average atomic mass is closest to the most common isotope of the element. That is not a rule that holds true for all elements, but it does hold true for most. And that is because the average atomic mass on the periodic table is a weighted average. And therefore, in most cases, that average will be close to the most abundant isotope. Again, we'll talk more about that later. So now I want to show you a lithium ion. Again, you can see a lot of this is the same. These two atoms have the same number of protons and the same number of neutrons. It is still lithium. Now what we have different is the number of electrons. So this atom has lost an electron relative to its neutral atom, and that makes it positive because you have 3 positives here and only 2 negatives. So you have a positive that has not been canceled out. And so lithium ion here has a charge of 1+. Now, the charges that elements take are predictable, and again, we'll talk about that more moving forward. But for now, that's an explanation of the subatomic particles and the roles that they play in features of the atom.